Assalamu alaikum warahmatullah. Welcome everybody to the NLP Ramadan program. This is a free program that we offer every year, and alhamdulillah since 2018, and we have transformed a lot of lives through these free programs. So we are still in the process of understanding the NLP cycle, the NLP pre-processing cycle. Yesterday we talked about the importance of learning NLP. We talked about the component of NLP, NLU and NLG. We talked about the tasks. We talked about the type of analytics, the 5 types of analytics: the lexical, syntactic, semantic, discourse, and pragmatic analytics. We talked about in examples of NLU, examples of NLG applications. Then we talked about the process. It starts from data to knowledge. Then we talked about some of the pre-processing steps: tokenization, removal of the stop words, punctuations, special characters and numbers, and stemming and lemmatization. So we are going to continue from where we got left yesterday. Today we are going to talk about some libraries, some great libraries that you could use in NLP. So there are a lot of libraries that you could use. So natural language processing, NLTK, is one of the most common library that is designed for NLTK. It's used for modeling, for preprocessing, for parsing, for tagging, semantic reasoning, and for tokenization. Then text blob is another beautiful library. Unfortunately, this text blob has not been updated, I believe, since 2017 or 16, 17, 18. Core NLP. This is a library designed by Stanford University NLP Lab. Of course, SciSpicy and GenASM, which is a Python library used for topic modeling. Polyglot. We got PyNLP, QPy. Flare is another great library that you could use for NLP as well. And of course, you could use the basic scikit-learn library that is used for machine learning and for supervised and supervised machine learning, for data preprocessing and for data modeling. Pattern and vocabulary, I never use them, but there are other libraries that you could use to complete an NLP project. So NLP, unfortunately, still struggling with some challenges, especially the ambiguity. Now, we could, as a human, understand the ambiguity of words, but the machine might not be able to distinguish, the tone of what you. As far as I know, it could be some sophisticated systems they can do, but as far as I know, that in the traditional NLP, the system or the machine will not be able to distinguish between if I say I love you or I love you. So both of them, they mean the same, but of course one I feel I mean what I said. The other one, as I'm questioning myself if I really love you. So ambiguities, there are many ambiguities: lexical ambiguities, syntactic ambiguities, semantic and pragmatic ambiguities. All of these ambiguities would stop or prevent a computer to understand the true meaning of a text. So when you are working on NLP, you need to consider these ambiguities. Otherwise, your analysis might not be as accurate as you want. So that is the presentation from yesterday. Today we are going to talk about the pre-processing. As they already we talked about in the session or session number 1 or the first session on Monday as data scientist to apply artificial intelligence, to apply a machine learning or deep learning algorithm to a given data set. We got to convert, we got to translate that data into data that can be understood by a machine, into numerical data, into zeros and ones, into scaled numbers, scaled numerical data. Either the data is a text or a graph or an audio, video, or anything. So we got to convert the data into a tabular data. NLP, the way we do that is after pre-processing the data, then we need to vectorize. So the process of converting the data into data that can be understood by a machine is called data vectorization. So there are many types of data, as you might know, you already know. We got the structured data. This is the most common data, or the data that we have most of the algorithms and scientific methods built around. So we have rows and columns, and the machine or the systems or the computer is will make an attempt to learn the underlying structures of relationships between the elements of your data across tabs, columns, and across records. And this data, it's easy to use. As said, most of the algorithms, they are built on the tabular or rectangular data. Second type of data is called semi-structured data. It's not 100% structured and it's not 100% unstructured, but there is still a method of navigating through your data to find an element. An example of semi-structured data is XML and HTML. They have certain type of ordering, certain type of structure, but it's not 100% structured. It does require some effort, little effort, to convert this XML and HTML data into a structured tabular rectangular data. The third type is quasi or quasi structure, depends on your pronunciation. So this all it's not yet 100% unstructured, but it has a little of structure in it, and it does require a lot of effort to convert it into an actual tabular rectangular data. An example of this quasi-structured data can be found into clickstream, JSON files. These all called quasi-structured data. And finally, we got this unstructured data. There is no structure, no format, no unknown format. In a tabular data, we have rows and columns, and we can definitely apply any descriptive analytics method, statistical analysis method, data visualization. We can dive deep into this data easily to find patterns, find the relationships, find the signals between the elements of your data. Unstructured data, like PDF, like text document, images, videos, audios, it's really hard to navigate through to find, to extract, to retrieve some information or to extract some knowledge. So what we need to do is, with this text, we need to convert it into structured data. We need to convert this data, we need to transform this data into a structured data, into a data where it has rows and columns. So we can apply easily the existing studies, the existing algorithms that we already have in the market. Then the question, how do we do that? How do we convert a video into rows and columns, or a text and that is what we are going to learn today. So the very first thing that we gotta do as data scientists is convert or split the entire document into smallest unit called tokenization. The process of converting or splitting your documents into smallest unit is called tokenization, and the small units are called tokens. So why do we need to do that? Is because it will make it easy for us to navigate every token to determine if it's a token that that we should keep, or a token that we should remove. It does not have any value, statistical value, and also it helps us to understand the statistics of these tokens, the frequency, the importance, and the frequency and the importance of these tokens. So for example, this is a sentence in a compact mode with a custom styles. So this is a sentence, and we convert that, we split that into tokens. So so we are going to navigate through. Once we tokenize, then we are going to look for punctuations. We can look for numbers that we need to remove or translate into digit. We can look for search for white spaces, search for stop words, and also special characters. And it's going to make it easier for us to stem and limitize these tokens to keep only the root. So the very first thing we gotta do is tokenization, and as we talked about yesterday, there are two types of tokenization: sentence tokenizations and word tokenizations. Sentence tokenization is splitting the entire corpus, the entire document, into sentences, and start analyzing, applying statistical analysis, understanding the importance of sentence within the corpus and within the whole documents. And the same applies to words. So tokenization is breaking up your text into small pieces by separating words with a space and punctuation. Okay, that is the very first thing we're gonna do. And today I'm going to show you a demo of how we can do that. The second step, once we tokenize our data, our documents, then we are going to look for any tokens, anything in the data that might not have a value whatsoever. Punctuations, we are going to see hundreds of punctuation in a paragraph, different punctuations, but their value, they don't have any value. So we need to remove them. Why do we need to keep something that wouldn't add any value to your analysis? And also common words, like where, when, how many. These are common words. We need to remove them. They don't have any value. And of course, some of words that you might feel like and might not add a value, you might need to remove them. And when you remove, for example, if you were to remove they, and, a, comma, full stop, on, the, there is going to be a space. There is going to be a space in there. That is what we call white spaces. So we need to remove stop words. We need to remove punctuations. We need to either remove numbers or convert them into digits, or and also we need to remove special characters. But when we remove them, we are gonna have the empty space, the space that holds those tokens that we remove. So we need to remove those spaces as well. Otherwise, you are gonna find that the most frequent maybe tokens within your paragraph is a space, and space does not have a value. So once we remove the stop words, the punctuations, and the special characters, numbers, white spaces, then we need to look for keeping just the root of a word. Help, helping, helps, helper. They are, for the computer, it's 4 or 5 distinct, unique words, but in reality, it's one word with prefixes, suffixes added, and they mean the same regardless of the tone, regardless of the prefixes and suffixes. So what we need to do is we need to remove anything that's been added to the word, to the root, and keep only the root. There are 2 processes of doing that. One of them is called stemming, and the other one is called lemmatization. Both of them, they pretty much are doing the same thing, but of course both of them, they have pros and cons. Stemming is very fast. If you have billion of tokens, stemming is just a blink of an eye, could only stem your tokens and keep the roots. But the drawback of stemming is it does not correct a spelling. Lemmatization, it does more than stemming by simply looking into the applying semantic analysis and syntactic analysis to a given token, and also compare the root of a word to an online dictionary for spelling correction. So it takes time. It takes time. Ahlal, please mute yourself, otherwise I'm going to dismiss you. Ahlal, if you jump in the mic one more time, I'm going to dismiss you, unfortunately. Thank you. Okay. So, as I said, there are 2 types of keeping the root of a word, and we could do the stemming. It's fast, but it does not fix the spelling of a word. And lemmatization, it's very slow, but it has a better turnaround. And if you have a superhero computer and a small data set, probably lemmatization might work. But if you have a huge billions of record of columns or billions like ChatGPT, maybe lemmatization might take a huge amount of time. Okay. So in stemming, there are many type of stemming. Poster stemming, Lancaster stemming, regular expression stemming, and snowball stemmer. So there are many type of stemming. Which one to use? It doesn't really. It doesn't matter, but in general, just use one of them. I don't really know honestly what the application of each of any. I never thought about any specific application, but I used the Porter stemmer for all the projects that I worked in the past. But today we are gonna try all of them just to give you an example, to showcase what is the actual difference between this type of stemmer. And also to better understand the true meaning of a word and to better apply NLP to extract the right information from a given text, we need to split our data into post or part of speech. We need to identify the nouns, the pronouns of adjectives, verbs, adverbs, prepositions, conjunctions, interjection, and determiner. So the system can do that. NLP comes with tools that can definitely identify the part of speech for a given token, which is going to help us, of course, to understand the true meaning of a word, and definitely would help us to extract the right information out of a given documents. So here is an example. Mary had a little lamb. This is a noun, verb, determiner, adjectives, and a noun. So the system can do this. Another things that we might need to consider when we are working on an NLP project is the name entity recognition. Is recognizing the entity. If it's a person, is it a person? Is it an organ? When we are looking into a token, so we need to determine what is we need to recognize this entity, the true nature of this token. Is it an organization? Is it a name? Is it a date? Is it a place? Is it a geographical location, etc.? And this process is called name entity recognition, or NER for short. And NLP, all of the packages that most of the packages that I've used in the past on NLP, like NLTK, they come with this built-in function to help you determine recognizing the entities. And with your understanding of entity, of course, would help you to extract the right information out of a given text. So now, once we clean, pre-process the data, clean it, pre-process it. We identified the part of speech. We identified the name entities recognition. We applied everything, anything we want, and we still have a text. We still have tokens. So now we need to convert the remaining text into a tabular data, into rectangular data, into rows and columns. And there are many methods that we can help us to make a digital or a numerical representative of the words that are the tokens, the words in the token formats that we have left. So we need, that is what we call numerical vectorization, or simply vectorization. Is converting the remaining words, clean, ready to use words into a vector. Many methods, some of them, they capture the true nature of words. Some of them, they capture the semantic and syntactic elements of the words. Some of them only they capture the syntactic elements of a word. Bag of word is one method. It's simply what we do. So we got a text, and we got many words. So we convert that text into a tabular data of number words, all the unique words in that document, and the frequency of each word. So counting the occurrences of a word in a document. So you create, for example, we got love, we got you, we got, for example, I, me, then we got document 1, document 2. So love appeared 15 times, 1 time, you 7 times, 3 times, 1 is 7, me is 3, 5, etc. So now we got a tabular data. This is what we call bag of words. How many, we counting how many words, how many unique words, and how many and the count of each unique word per document. A document, it could be a line, it could be a sentence, it could be a paragraph. So we started from a text, something like this. Now we end up having a tabular data, and with this tabular data we can use statistical analysis, we can use descriptive analytics, we can use number 3, we can use EDA maybe. Number 4, we could use data visualization. Okay, and we start understanding, learning what we have. and of course get the information we are looking for. So these are called backup words of frequency vectorization. Okay. So in backup words vectorization, every document from the corpus is a collection of documents, presents in a vector whose length is equal to the vocabulary of the corpus. If you have 5,000 unique words, then the number of rows that number of records that number of columns that we are going to have is 5,000. So a column per unique word. Every unique word will have one unique column, and the content the rows are the number of documents. Document 1 and 2 and 3, or paragraph 1 and 2 and 3, or corpus 1 and 2 and 3, etc. And of course, the cells are the frequency of these words, these 5,000 unique words per the given documents, or the given documents. Okay, so there is another one. It's called frequency vector. It's similar to the backup word. It's simply count the frequency of each word that it appears on these documents. More advanced. Here is an example. Here is an example. This is called count vectorization. Backup word, frequency vector, they are all called count vectorization. It simply counts how many unique words that we have, how many documents that we have, and how many unique, and what is the frequency for every unique word that we have in the entire documents per every individual document. What is EDA? Exploratory data analysis. Is exploring the data, try to find the quality of your data, understand the quality of your data, understand what you have in the data, understand the correlation, understand the relationship, understand the skewness, the distribution, understand so many things about the data. That is what we call EDA, exploratory data analysis. And the person, I believe, the father of this EDA, his name is Dr. John Tukey. He is a statistician. His name is John Tukey, and he published a book, I believe, back in 1970. John Tukey. And this is him, and this is the book. Exploratory Data Analysis EDA, and I believe this is 118. It's an old book, but still used. So you are not going to be a data scientist without understanding the EDA, without applying EDA to your data. So it's 118, and I think you could find something online cheaper. Okay, so here is an example. We got two documents. Document is not what we are familiar with. A document, it could be a sentence. So the word document could be a sentence, could be a word, could be an actual document. So here we have two documents. How to format my hard disk. This is doc 1, and hard disk format problems. This is document number 2. Okay, it's how to format. So of course we are going to remove stop words to maybe my hard disk format problems. Remove the S. So now we got how many we are going to get unique words. So we got 1, 2, 3, 4, 5. So we got disk, and we got document 1, document 2. So disk, we got disk in document 1, and we got 1 in document 2. Format, we got 1. How? We have it in document 1, but we don't have it in document 2. That is what we call, bag of words or count vectorization. It's simply finding 3 things: finding the number of unique value words or tokens. Number 2, finding the number of documents. In our case, we got 1 and 2. Number 3, calculating the frequency of all the unique words per the given documents. And voila, you got tabular data. And now you can use the statistical analysis, ADA, data visualization, descriptive analytics to dive deep and zoom deep into this data to try to find some patterns or signals or some information that you can help the business to make a better decision. Okay, so there's other techniques. They are much sophisticated or much advanced. One-hot encoding is similar to the count vectorization, except the one-hot encoding is simply what it does. It finds so we are going to have a 0 and 1. It's not a number, so it finds the number of unique words, and it finds the number of documents, and it looks for a word in the document. If you have a word in that document, you give it a 1. If you don't have a word, we give it a 0. So disk, like for example, we could have let's say that we have disk. We have 2 disks in here. How to format my hard disk? So we are going to have 2 here and 1 in the other one. And this is the count vectorization. For one-hot encoding, what it does, it is going to look for for a disk. Do you have a disk? Yes. So we are going to give it a 1, regardless of how many disks that we have in document 1, and we are going to have 1 here. If we don't have a disk in there, we are going to get a 0, and the other one we are going to get a 0. So the one-hot encoding, of course, without going behind the math, without going deep into its mathematical application. So one-hot encoding will assign a 1 to a word if it does exist in that, if it appears in that document, and a 0 otherwise. And voila, then you have a tabular data. So the most common methodology to vectorize your tokens is called term frequency and inverse document frequency, in short TF-IDF. This is the most common. Of course, there are some sophisticated advanced using deep learning, but these are the most common. And this terms frequency, inverse frequency, what it does, it takes into the consideration the context or the importance for the count vectorization method, regardless what the method is, frequent vector or bag of word. They don't care about how important. They don't consider how important a token is to its documents or across the entire corpus. Simply finding the occurrences or the 0s and 1s. Whereas the term frequency, it does take into the consideration the context, and it studies the relative frequency or rareness of a word within a document. So you'll get the values, and also you'll get the how important you will get a value of a word and the importance or the weight of that word within its documents and across the entire corpus, which is a collection of documents. So here is an example. This is the map. This is the map. The term frequency is the occurrences of a word in a document D divided by the number of words in a document D. So to simply find the term frequency. Then the second part is IDF is it's a natural logarithm of the total number of document N and corpus D divided by the number of documents in the containing word. And you got something finally. This is the final. So we got some words and we got their IDF representative. And of course we can use this data to determine the relationships, the importance, and to extract some information. So term frequency and verse document frequency is a very common method of converting your text into tabular data. And it does calculate the frequency and of course the importance or the weight of a word within the context of its documents and the entire corpus. Okay, the most advanced techniques of looking or converting your tokens into a tabular data is what we call word embedding. Word embedding is embeds words within a similar meanings or relationship within another word. So this is an algorithm that was designed back. It used Mikolov in 2013. It's an algorithm using C++, but now it's been transformed into a Python library. It's called GenSim. And one method of this word embedding is word to vector. It's simply trying to connect a word to another word using their relationship, their meaning, their syntactic relationships. And there are other methods. One of them is called Glavy. Glavy is this Glavy, what it does, it's already been prepared, so it provides a word which it's a numerical representative. So it's a dictionary that you download from online, and when you have many tokens, you convert them to the numerical representative in that dictionary, and you start analyzing your data. So these are some of the methods, without of course explaining them in details, unfortunately because of the timing. We have 10 minutes left, and I need to take you through some of the examples of how to transform a text into tabular data. So you should be able to access the canvas. If you have access to Canvas, you should be able to access these documents or these Jupyter notebooks. Unfortunately, I cannot teach you Python at this point of time, but you are going to learn some of this with Professor Ed towards the end of the program. So this is the file I'm using. So the first thing we gotta do is we gotta text. So let's go to let's say go to Amazon, go to Yahoo. Okay, I got this. I got this text, for example. I don't have time to read it. It's a lot. Can NLP help me understand what is in this text? That's what we are going to do. So I'm going to copy the entire text. Okay, and I'm going to create Okay, I'm going to create an object, and I'm going to pass to it the text. Okay, but before we do that, let's simply install some of the packages that we are going to need. Okay, so we are going to create I simply created a function. It's called clean text, and using a regular expression, which is a Python library. This regular expression, what it does, it's going to look into all these text, and it is going to remove anything that is not a string. Anything that is not a string. Adele, unfortunately, I am not following you on the chat. So if you have a question, please raise your hand, and I will be more than happy to give you the mic. So let's create the variable, and let's take a look into the variable one more time. Yahoo, and voila. So we got this text. So we got some special characters in there, we got numbers in there, we got punctuations in there. We got numbers. So we got a lot of garbage in this text. So what we need to do is we are going to apply the regular expression function that we just created all the way to the top, and we are going to keep only out of this text, we are going to keep only strings. So I'm going to apply the function. Okay, let's see, and here we go. So now we got tokens. We got Baltimore, key, bridge, collapse, latest, update. We got 6 in there. We need to remove it. 2 off, and of course we got a lot of stop words. We just removed anything that is not string from this text, and now we got a full list of tokens. Of course we got small some apostrophe. So when we remove the countries with an apostrophe, it doesn't remove the apostrophe, and it keeps the S. President, announce, these are all special the stop words. Let's create another sentence. Small sentence. A 16-year-old boy with a hot teacher. He said blah blah blah. So we got a sentence. We can use clean text, which is a function that we already built to remove anything that is not string from the text. Okay. And now let's take a look into the sentence. Now, sentence 2. This is sentence 1, and this is the clean sentence. Okay, this is sentence 1, and this is a clean sentence. So there is no 16 years old, 16, there is no hyphen was removed, there is no special character. Okay, so it's a clean words, but still we got a small one character word. We got a lot of garbage in this still that we need to remove. Okay, so maybe let's stop here. I just want to give you a chance before I dismiss you. Just see if you have any question, any concern, and of course we are going to continue this training tomorrow, inshallah. So any question, any concern, please raise your hand. Don't jump on the mic, and I will be more than happy to address any concern you might have. Yes, Adil? Adil, the mic is yours.
Hello?
Yes.
So I have a question. When we do the tokенization and all the transformation, how we can keep the meaning of the text?
So So maybe the meaning of a text might be lost, but the underlying structure, the mathematical true meaning of a text, will be kept. So the underlying structure will be kept through whatever the transformation method that you are using. If you are using word embedding method to convert, you could keep some of the true meaning of a word compared to other transformation method. Yes, the meaning is there. The underlying meaning is there. It's been reserved mathematically. Ahab?
Jazakallah khair. So just a couple of questions, inshallah. The first question is, do we have access for the Jupyter notebook that you're showing us?
Yes, you are going to have it today, inshallah.
Through Canvas, correct?
Yes, through the Canvas.
Okay, the other question I have is, like I remember you saying something about words being in columns earlier instead of rows. Did I hear that correctly? Like before showing us that the words were in rows, I think you mentioned something about them being in columns.
Yeah, rows and columns. Rows and columns is what I was talking about. That is structured data. Most of the scientific methods have been built, studied, trained, tested around tabular data. Text does not have a form. So we need to convert this text into rows and columns. And to do that, we got to clean it first. Once we clean it, what do you mean by cleaning? We need to remove stop words, white spaces. We need to remove punctuation, special characters, and numbers, and convert it into rows and columns using word embedding, using IDF methodology, using the count vectorization methodology. There are many methods that you could use. Some of them, they simply represent the frequency of a word. Some of them, they represent the weight and the meaning of a word.
So like in the case that I'm showing right now on this slide, they are in rows, not in columns. Is this what it's typically?
It doesn't matter. Yeah, it's still. Yeah, you could convert it the way you want. You could make this. You could make this. You could simply as an example. You could make these columns and make the documents as the rows.
Okay. Thank you.
You're welcome. Okay, Mustafa Al-Malahi.
Thank you, Mr. Midwani, for your presentation. Good presentation. My question about if we have hybrid, for example, text and image, what we can do for customization?
So, for the images, it's another specialty within data science. You will be using deep learning, and images is nothing but range of pixels. So you need to transform the image into pixels and flatten those pixels through a process. You'll be using most likely CNN, convolutional neural net, to filter the pixels and keep. There is a whole process that you can use to convert the image into tabular data. Either you are using images and the text, all of them has to be converted into tabular data. Of course, the conversion is different. The way you convert an image into tabular data is different than the way you convert a text into tabular data. An image is a pixels. And of course, you need to find the pixels, the size, the height, the weight, and the channel. Is it black and white? Is it red? Is it color? Then you convert that into pixels, and of course, you reduce the dimensionality of these pixels by filtering out. You multiply in the entire image by a filter, 3 by 3, 4, 5 by 5, to reduce unneeded or unwanted pixels, and keep only the relevant or the most necessarily or the most important. And the text is different. You you clean your data first, then you vectorize it using one of the methods that we covered today. Okay?
Thank you so much, Mr. Ibrahim, for your presentation.
Khalid, Shahnaz? Shahzad.
Yes. Two quick questions. One is that I would like to know that, so during this entire course, are we going to go through some kind of a hands-on practice, or are we just going to go through the course material and make the concept clear? This is my first question.
Because of 1 hour a day, brother, and because of Ramadan, unfortunately. So what I could do going forward, then you will have access to the code ahead of time. So you download the codes to your computer and you follow up with me. We have only we have only 1 hour, unfortunately. So 1 hour is not enough. So this is a 3 hours to 4 hours and presentation course.
Sure. And the second question is when I see that in one of the map review, I see there is a formula mentioned using the natural log. So is there a specific reason that they have to use the natural log rather than taking the standard log? Because this is mathematical terminology. I was wondering, are you going to explain or maybe down the road something like that?
There is honestly, I don't know the logic behind it, but that is the math they use to design this these conversion methods. It's done through math. How they did it, I have no idea.
Okay. Thank you.
You're welcome. Okay, folks, that's it for today. I'll see you guys tomorrow. Tomorrow is going to be my last presentation on NLP. And the following week, we are going to do either cybersecurity or cloud computing. Please stay tuned, stay with us, and please help us spread this knowledge through sharing our our YouTube channel. جزاكم الله تعالى خيرا. صحفتكم. السلام عليكم ورحمة الله تعالى وبركاته.
Let's